All right, welcome to the latest in the series of homework help videos. I've got Penny Miller with me. Penny is not able to speak over her microphone today, so she's going to be in the chat window. She has listed a few problems down in the chat window for us to take a look at. So I'm going to take us out to my web browser, and actually let me go ahead and pull up my Math Lab here. My Math Lab does not, or Collaborate doesn't like for me to log in and out of programs while I'm in it. So I'm going to go ahead and get logged into my Math Lab and go find these problems that Penny wants us to look at together today. Okay, so let me do this. I'm resizing here. All right, let me take you out to the web. And Penny, you should be seeing my desktop now. Great. Okay, so the first one was Section 1.4, number 11. Let's go see what that one looks like. And what I can do is I can take a screenshot of it, throw it onto the whiteboard, and then I can write all over it. Ooh, if my pad is still on, I might have to plug it up. Okay, it's good. Let me just make sure. Yes. All right. So, let's see, homework 1.4. I got to open all these up so it'll let me get to the questions.
In this example, we will use data.
Okay. So number 11, let's see what we got here. Homework question roulette. And I misspelled section. Okay, so let's see. I'm going to go ahead and take a screenshot of this. It should throw it onto the whiteboard for us. Yes. Oh gosh, that was a terrible. Oh, okay, not as bad as I thought it was going to be. Terrible picture. I mean, still not great, but you know, that's how it goes. All right. So this question is an equation in slope-intercept form. It says give the slope and the y-intercept of the line whose equation is given below. Then graph the linear function. So let me get my pen. Just to remind you, slope-intercept form is y equals mx plus b. M is always the coefficient on the x term, and m is your slope. The formula for that, if you're having to find it, is y2 minus y1 over x2 minus x1. The x1, y1, x2, y2 being 2 points on the line. So you don't have to find the slope for this when it's given to you, but I just wanted to throw that in there. So you can see in our example here, sitting in the position of m is 5/7. Just a quick reminder on counting slope. Let me get a different colored pen here. Counting slope, you always have your change in your y value over your change in your x value, and you have positive and negative values of each of those. Positive y is up, negative y is down, positive x is right, negative x is left. So with this particular slope, we're going to be moving up 5, right 7, up 5, right 7, up 5, right 7. from the y-intercept. The y-intercept is the b value. So that corresponds to the point 0b. So 0 will always be your x value for any y-intercept, and then whatever value for your y coordinate. So in this case, b is -2. This is all the information that you have to graph a line in this form. So to graph a line in slope-intercept form, the first thing you do is put a point on your y-intercept. 2 points determine a line. So as long as we can get one other point, we can graph the line going through those 2 points, and that is a unique line going through the 2 points. The way I get my next point is from that y-intercept, I count my slope, and that's going to take me to the next point on the line. So I'm going to get a different color here to show you me counting the slope off. And I want to move from my y-intercept up 5. 1, 2, 3, 4, 5, and write 1 and put another point. And that's all I need. I'm ready to graph. That is not a line. Let me try that again. That was awful. Maybe I just need a different color to help me get my marks a little bit better. So let's see. Graph the line. That's a little bit better. There's your line. Are you good on that one, Penny, or do you need to talk some more about it? And by the way, if I ask you if you're okay or not, you don't have to type. I see that you're typing something. But if you look right above our names in the participants panel, you'll see a check with a box around it. That's a drop-down menu. You can either give me a green check or a red X. There you go. So you're good. Excellent. I'm going to go ahead and clear that out, and we'll move on to your next question. So 1.5, number 7. Let's go get that. And let me see. I want to go back out. Resume sharing. I'm getting better at this. Leave page. Now I want to go into 1.5. I got to click on all these again. Sorry.
In this example, we will stop.
The diagram helps. Why wouldn't you? Oh, I only moved over one. You're right, it was 7. I'm sorry. That, pardon the language, that was a brain fart. I just wasn't looking. I glanced and saw 1 instead of 7. I'm glad you picked up on that, though. That means you know what you're doing. Okay, good. So 1.5, number 7. Sorry about that to everybody else, too, that's going to watch this. Word problems. No, I'm just kidding. I know that that's what every student says when they see a word problem pop up. No, not a word problem. Okay, let's see what this says. Oh, let me read it here first. In 2000, 52% of the residents in a large city regularly use newspapers for getting news, and this has decreased at an average rate of approximately 1.5% per year since then. Find a linear function in slope-intercept form that models this description. The function should model the percentage of residents, P of X, who regularly used the news outlet X years after 2000. All right, let me take a screenshot of this and send it to our whiteboard. There we go. Okay, so it did cut me in half that time. My head hurts. All right, that was stupid, I know. I always try to get a laugh out of people. I have difficulty being serious. Okay, so let me point out the important information that we have going on here. In 2000, 52% of the residents. And then we have decreased at an average rate of 1.5% per year. We want our function set up P of X equals, so they've got that there for you. And then another important thing is that X is standing for years after 2000. So let me start with this piece of information. In the year 2000, 52% of residents. Notice in your equation you're going to have X as in years since 2000 and P of X being percent that read the newspaper, I guess. So this is giving you the coordinates of a point. Every point in this problem, plane, whatever, is going to be in the form of X, P of X. Okay? So this particular information that you have is giving you the coordinates of a point, and that is going to be 0, and instead of writing 52%, I'm going to change it to a decimal because that's how we need to have it if we're going to do any work with it. 0.52. The reason the X coordinate is 0 is because X is standing for years after 2000. Well, in 2000, that's 0 years after 2000. Let me also point out that they have given you here the y-intercept. We just said on the last problem that a y-intercept is always going to have 0 as its x value and then some value for y. That is where that graph is going to cross the x-axis, just because of how they have this problem set up. Okay, the other very important piece of information is that it decreased at an average rate of approximately 1.5% per year since then. We learn in this section that average rate of change is slope. So whenever you see average decrease, average increase per year, that's going to be your slope. So let me get a different color. So decreased means I'm going to have a negative slope, decreased 1.5% a year. My slope here is negative. Okay, 1.5% is 0.015. So that's decreased 1.5% every 1 year per year. So I've got my slope and I've got a point. To write the equation in slope-intercept form, I want to start with point-slope form. So what I'm going to do, I'm going to go from point-slope form, y minus y sub 1 equals m times x minus x sub 1, and I'm going to take it all the way down to slope-intercept, y equals mx plus b. In regards to my problem, this would look like this. So if I wanted to use x and p of x, this first form, point slope form, would look like this. P of x minus p of x sub 1 equals m times x, minus x sub 1. This being x sub 1 and this being p of x sub 1. Okay? And m is my slope that I have right here. So I'm ready to plug all of this information in, take it from point slope to slope-intercept form. Get green. Okay. So p of x minus p of x sub 1, which in this case is 0.52, is equal to slope, which is negative 0.015 times x minus x sub 1, 0. All right, so hopefully you can see where each thing came from and went to. All right, now all I need to do, okay, great, thank you for the check, Cindy. All right, so now all I need to do is rearrange this until it looks like y equals mx plus b, or p of x equals mx plus b. So p of x minus 0.52 equals, I'm going to distribute my slope to each term inside my parentheses there. And that gives me negative 0.015x, and negative 0.015x times 0 is just plus 0. Okay? Now, I'm going to add 0.52 to both sides, and I end up with, oops, wrong color. Try to keep things color-coded so you can see where they came from. P of x equals negative, that goes away right there, negative 0.015x plus 0.52. Notice my slope shows up right here, attached to the x variable. And remember, when we formulated that point right there, I told you, hey, that's a y-intercept. Because x is 0, it shows up right there as your y-intercept. And you say check. So I'll go ahead and move on to your last question. Let's see, 1.6, number 9. What have we done? Number 9. Get those okay, so thank you, but you're very flattering. I do enjoy singing, though. I usually have music in the background at all times. I don't like the institutional hum. It puts me to sleep. So, And now I'm just bopping to what's left in my brain from when I drove to work this morning. All right, it was Queens of the Stone Age, by the way. Collapsia is the name of the song. It's one of my favorites by them. And I went to their concert this last Saturday night, and it was awesome. Anyway, okay, so transformations. From lecture video 1.6. Oh, actually, let me take a screenshot so I can start writing all over this. Let me see if this will expand and leave these big. Okay, we'll at least leave that one big. Let me see if it'll put that on our screenshot so we can see our function bigger. Okay, yeah. And then we're going to choose which one has been transformed here. Okay, so from lecture video 1.6, we find out that transformations can be seen in a function. Let's see. I'm just going to write the general forms here so that when I say A, B, C, and D, you know what I'm talking about. A, not what I wanted. A, well, let me grab the pen. A, there we go. A is the coefficient that lives outside the function. Now, they're not telling you what this function is. It's a weird one. It's just two lines that they've drawn. So they're just calling it general f of x as the function. So A is the coefficient that lives outside of the function. The function is f of x. Minus plus. Okay, so now I'm going to fill in the other pieces. We have a b coefficient that lives inside the function. We have a c value that is subtracted from the x, the independent variable, inside the function. So if we're talking about something squared, this is happening before you square it. And then the final one is the constant tacked on to the end, the d value, and that lives outside the function. Okay, so for this particular problem, I'll just run down real quick what each of these do. A, you have two things that it does. Depending on the sign, so positive or negative, if it's positive, this thing sits in the same position as the parent function. If A is negative, this thing reflects over the x-axis. So it flips over the x-axis. B, oh, I'm sorry, more about A. If the value of A is greater than 1, this thing has a vertical stretch. If the value of A is between 0 and 1, this thing has a vertical compress. So a shrink is what your book calls it. Every other book I've taught out of calls it a compress. So that's why I call it a compress. That's just what I'm used to calling it. The B value. The B value is the coefficient on the inside of the function. This represents horizontal movement. So the sign of the B value, if it's positive, it's in the same position as the parent function. If the B value is negative, it flips over the y-axis, so left and right wise. The value of that coefficient, B, if B is greater than 1, it's just the opposite of A. If B is greater than 1, it represents a horizontal compress. If B is between 0 and 1, it's a horizontal stretch. You'll find that a vertical stretch looks just like a horizontal compress, and a vertical compress looks just like a horizontal stretch. Those are the stretching and compressing can be very confusing. I'm not going to give you much with those, and as a matter of fact, I'm not going to give you any on your quiz that have a B stretch or compress. It may have a B reflection across the y-axis, but the only stretch and compress I'm going to give you is outside the function, so vertical stretching and compressing. Oh good, my brain hurts. Yes, I know. As a matter of fact, I know you haven't seen the 1.6 lecture video. It was 3 slides, and it took us an hour and 15 minutes to get through. That's how hefty that topic is. The C value inside the function is subtracted from the X. This represents horizontal shifting of the function, so left and right movement. The D value outside the function represents vertical shift, vertical up and down movement. So I'm going to point out what we have happening with this particular function, g of x. All right. Where's my pen? There it is. I'm just going to write this function bigger so that I can point out what's going on with it. Let me get a thicker pen too. Okay. G of x equals -1/2 f of x plus 2. And I'm actually going to rewrite this. G of x equals -1/2 f of x minus is in the form -2 in parentheses. So you have 3 things happening here. 2 different values, but 3 things happening because remember A does 2 different things. Oh, wow. So A is negative. The first thing I'm going to point out to you is that just because A is negative, first I'm going to highlight our function here, f of x. So this is our f of x. Because A is negative, that means it flips over the x-axis. So if I was just considering the negative part of A, my function would already do this. Okay? But that's not all that's happening to the function. So it's flipped, and because the value of A lies between 0 and 1, or the absolute value of A really lies between 0 and 1, it has a vertical compress. So I'm actually going to erase these green lines that I've drawn so far and add the compress in there. So it reflects and it compresses, so it might look like this. Like it's been squashed down. That's the compress. The last thing that happens is, because minus is in the form here, and it said plus, I changed that to minus a negative, because minus a negative is a positive, but minus is in the form, so you got to have it there. So this is minus a negative. So the C is -2. That means it shifts left 2 spaces. So my final, I'm gonna delete these now. So we flipped them, we compressed them, now we need to shift them left 2. That is your transformed function, and it is C. Yay! Okay, you brought some good questions to me today, and I'm sure your classmates will be very happy that that they were able to revisit these, especially before the quiz opens up on Thursday. Penny, I appreciate you keeping your appointment with me today and bringing such good questions. Definitely need to review this one again. Very good. Have I succeeded in answering your questions today? Yes, it really is. Very good. Have a wonderful afternoon, and good luck on your quiz, too. It opens up Thursday. Thank you. Bye-bye.